Right, let's look at a few of these combined. If I, for example, I'll just change that back to x for now. If I make this 3 sine x minus 2, now you need to be able to look at equations like this and understand what's happening to the graph straight away. So we can see from this that the amplitude is 3, so it's going to be stretched vertically, and the principal axis will be y equals negative 2. So there's going to be a translation downwards 2 units. If I just graph that, it's gone off there a little bit. I'll just change the axes so we can see that. Just take that down to minus 5. Okay, so we can see the equation is y equals 3 sine x minus 2. So the principal axis now is y equals negative 2. That's where our line of symmetry is. The amplitude, well, it's for the maximum to the principal axis is now 3 units, 1, 2, 3. Okay, or if you prefer, from maximum to minimum is 6 units. So the amplitude's half of that. You can see that because I haven't done anything to the x here, I haven't multiplied or divided x, the period is still the same. I still have to go 360 before it starts repeating itself. Let's make some more changes. Right, let's think about what's happening here. So I've put a negative sign at the front, so that's going to cause a reflection. So what was negative will become positive and so on. And I've changed the x here. So I've multiplied x by 4. That means the period's going to get a quarter of the size. So instead of being 360, it'll be 360 divided by 4. So it'll be 90. So you can see that's what's happened. So I've got, first of all, instead of the sine curve going up to start with, it's going down. That's the negative sign that does that. And the period, instead of being 360, well, I only have to go 90 degrees now before it starts to repeat itself. Let's just do one more. Put some decimals in, which doesn't really change anything. And we'll have let's have a division here. Let's have x over 2, and we'll have, say, 3.8. Okay. Now this looks very complicated, but it's really no more complicated than the others. We just look at the parts. The amplitude will be 2.5. Now here we're dividing by 2. That's actually going to make the period bigger. So let's do a bit of work on the side here. So B is a half. So the period is 360 divided by a half. Of course, if you divide by a fraction, it's the same as multiplying by its reciprocal. So it's just 360 times 2, 720. So the period will be 720, and the principal axis will be y equals 3.8. It will be shifted up 3.8 units. Let's graph that. I'll change my axes again. Actually, let's have a think about what values we need for our axes. Now, actually, a very important point is because from the basic sine function, you can see that the highest value you can get from the basic sine function is 1, and the lowest value you can get is 1. That's all you'll ever get out of a sine function before you start multiplying and adding things. Okay, so sine x over 2, that will still only give you values between 1 and negative 1. So when we multiply that by the amplitude 2.5, from this bit we'll get values between negative 2.5 and positive 2.5, and then we're just adding 3.8 to that. So the highest value we'll get here will be 2.5 plus 3.8, so that's 6.3, and the lowest value will be negative 2.5 plus 3.8, well, it's the same as 3.8 minus 2.5, so that's 1.3. So this will go from 1.3, which we can see here, this is 1.3, to 6.3. So if I'm choosing my axes, I don't need to go down quite so far, and it'll go up to 6.3, so let's say take it up to 8. Okay, and there we can see. So the principal axis is 3.8, that's here. The amplitude is 2.5. Okay, it's a bit difficult to see these numbers, of course, but you can see that from here to here, that's 1 unit, 2 units, and then it's half a unit, 2.5 from the principal axis. And the period you see is doubled. This is the basic sine function period is 360, but when I go 360 here, I've only actually gone through half a period. But the entire red line here is a whole period, so it starts to repeat itself here, and that's 720. Okay, so hopefully that's given you an understanding of the relationship between the equation and the graph. Now, one thing we need to do with this is to model.